Graphs of factorized cubic functions. In the previous video, we were looking at doing very basic cubic graphs and also their inverses. So how does the graph change when I've got factors, and what we've been doing after all of those painfully long divisions of polynomials? Well, the way we draw them is still the same pattern. We start from the bottom left and move our way up. But what we're going to be doing is we're doing this in a very systematic way. So I'm showing you a few examples with some very generic x-intercepts. I'm going to be using pronumerals as my x-intercepts. So I've got x plus a, x minus b, x minus c. So for the purposes of this example here, I'm assuming that if it's got a minus c or a minus b, that's on the right side, because that's normally the positive ones. You might remember from your quadratics and things like that. So if I've got a negative one here, or this x plus a, that's going to be on the negative side. So what that means is that if I was to make this equal to 0, I would have three intercepts. One at negative a, one at b, and one at C, or one at C and one at B, doesn't really matter. So when I'm drawing it, I will start from the bottom left, move my way around, and move my way like so. Now, if you had some more information, some numbers, you could find a lovely y-intercept as well. Now, at this stage in your wonderful careers of education, you won't necessarily need to find the turning points. That's when we need to use some calculus and differentiation, so that comes much later. But for now, you can get away scot-free, as it were, from having to go and find turning points unless asked to with your graphics calculator. But, of course, you do need to be able to put in all of those lovely intercepts, like so. Now, if there's a great big old minus up there, well, these are still going to be the same. Just we're going to start from the top, that's all. And we start like this. And that's how it works. So you're connecting the dots by making very lovely loops. Now, for this one here, again, we're assuming that this is negative and this will be a positive one. You notice it has a squared. Much like in quadratics, when we've got a bracket squared, that's going to make a turning point, because quadratics have a lovely little turning point. So I'm going to mark that as negative a, mark this as b. We still start from the bottom, but then we make that, whichever bracket has the squared, has a little turning point. Oh, what's happened here? My graph has gone fuzzy. Try that again. Oh. Try that again. There we go. I don't know why my graph is getting all fuzzy, but it's okay. So there we are. So we have got our graphs accordingly. Again, if we've got the negative sign at the front, that means it's just been reflected in the x-axis. And so we're going negative a and b. And again, we're going to make a lovely turning point. So, make this lovely shape. And now if we've got the squared on the other bracket, then it still do the same thing, except this will now have the turning point. And so similarly, if I'm upside down, I'm going to go like this. And there we go. And then we're lovely and upside down. So now we need to actually sketch some graphs and draw a sign diagram. Okay, label your sketch your graphs and show the turning points with the axes. Now, a sign diagram is essentially, look, I'm going to sound a little bit sacrilegious here. I think it's a bit of a waste of time. But I also understand, because I've been in this business for far longer than I care to imagine, that it is a very good set of training wheels to be able to go and draw your graphs. So it is essentially a set of cubic training wheels. So here's my sign diagram. It's actually a number line. And it just reminds you where the x-intercepts are going to be. So for this one on the left here, I've got y equals x brackets x minus 1, x minus 3. It means I'm going to have intercepts at 0, 1, and 3. So we start from the bottom of the x-axis. We go up, we go across, we go down, we go across 3, and then we go like that. So it's a reminding you of how the shape works. -1, +1, and +2. So that means my smallest x-intercept is going to be at -2. So 0, 1, 2, 3. So it's starting it to go through -2, then it goes to -1, then it goes to +1. And again, just as a clarifier, that one relates to this bracket. This one here relates to this one. And this one here relates to this here. Similarly, this friend here relates to this one. This one here is to this. And that is to this. So now we just need to sketch the graph accordingly. It says do not need to determine the coordinates of the turning points, which is fab. So for the one on the left, I'm just going to find the y-intercept. So that's when x equals 0. Well, we know that as soon as I replace that first x with 0, everything's going to turn to 0. It's going to be 0 times 0 minus 1, 0 minus 3. So it's going to be 0. So there's our y-intercept. For this one on the right, so I'm replacing all those x's with 0. So it's -1 times by +1 times by +2. So that's going to be -2. Not the word 0, -2. So now let's sketch these beauties. Y is my x. So there we go. 0, 0, 1, 0. You could probably actually make that 1, 0 a little bit closer. There we go. 1, 0. It's 4, 0. And this one on the right, I'm going to go over here. So we're going from -2, -1, and 1. And I might just fix that up. So that's going to be 0, -2, that's 1, 0, that's -1, 0, and that's -2, 0. Now you might be wondering also, how do I know how big or small I'm making my little sort of curvy dents, where I'm supposed to my Harvey dents? No, I had a feeling I was going to do that. Bring that back at me. I mean, these bits, how do I know how big or small? I don't. I'm essentially having a little bit of guesswork that if my intercepts are very close to each other, that there's usually the turning point's going to be fairly small in between, because otherwise it will not curve very nicely. So similarly, if there's a big gap, it's usually a bigger turning point somewhere in between, because it should follow a very beautiful curve rather than it should really flow quite nicely. For instance, you wouldn't get a cubic that looks like, that's not a cubic shape. This is a cubic shape. So your graphs should look something similar to that. Sketch the graph for each of the following and draw a sign diagram. Label your sketch graph showing the points of intersection with the axes. Well, this one on the left, which we'll have here, we can factorize this friend, which of course we can factorize using the difference of perfect squares. And then we'll draw a sign diagram. If you find it useful, please let me know. I'm just not, I'm really not a fan of them. I know I'm supposed to love everything of maths. I just, back in my day, we didn't have sign diagrams. We just had to toughen up. So it's going to look like this, it's going to look like that, it's going to look like this, it's going to look like that. So again, it's just a reminder that one is this coordinate here. This one is that one there. And our friend in the middle is that one there. So what I'm going to do is I'm just going to find a y-intercept when x equals 0. Well, it's going to be 0, 0, isn't it? So y is equal to 0 cubed minus 0, which is 0. So let's draw this friend. It's going to look like this. See what I mean by having that beautiful shape? That's what we need to make sure we have every time we draw it. We want to make sure we have a very beautiful, that lovely, beautiful sort of half an ABC sign, if that works. That, as in like the Australian channel ABC. It's fine. Now we need to go and factorize this friend because it is utterly unfactorized. And of course, the friend about this is then we'll have to do some long division. So let's see. I've got a 3. I've got a 4. I've got a squared. I don't think 2 would work because that would be a 6, and that would be a 4, 16. No, that 18. Look, I'm feeling something about 3s. Let's go and find 3, and let's be happily wrong if I'm wrong. So this is going to be 3 cubed minus 4, 3 squared minus 3 times 3, 18, 27 minus 36 minus 9 plus 18, 27, let's see, it's going to be negative 45. 27 plus 18 is going to be 45. There we go. Good. So we've got x minus 3 is a factor. So we're going to x minus 3. We're going to do some long division. X cubed divided by x is going to be x squared. X squared times by x is going to be x cubed. X squared times by negative 3 is going to be negative 3x squared. And we're going to minus this friend. And that's going to be, those will disappear. Negative 4x squared minus 3x is going to be negative x squared. We're going to bring that 3x down. Negative x squared divided by x is going to be negative x. Negative x times by x is negative x squared. Negative x times by negative 3 is positive 3x. So that's going to make that negative 6x plus 18. Negative 6x divided by x makes that negative 6. And negative 6 times by x is negative 6x. Negative 6 times negative 3 is going to make that positive 18. Minus that. Go 0. Fantastic. So we've now got our factorized form, or almost factorized form here. X minus 3, x squared minus x minus 6. Two numbers that multiply together to get negative 6 add together to get negative 1. Well, it's going to be negative 3, and it's going to be minus positive 2. Oh, 2 would have worked. Well, there you go. So because that's, yeah, that would have worked. All right. Should have had faith in myself. Should have given negative 2 a go. Oh no, we better do our sign diagram first. It's better do the sign diagram. -3. Oh, oh, I just realized something. I wonder if you noticed it too. I've got two brackets that are identical. So this is an x minus 3 squared x plus 2 graph. We'll have a lovely different shape. So that's going to be -4, -3, -2, -1, 0, 1, 2, 3. And we'll do our sign diagram. So now, of course, this is going to be slightly different because we've got the turning point there. So it's going to look like this. Oh, actually, no, it's not. Idiot me. Because it's +2, so it's going to look like this. And there we go. There we go. Now, what we're then now going to do is we're now going to draw this graph. And we've got a x-intercept at -2, and then we've got the turning point at +3. So let's go and find the y-intercept. X equals 0. So that's going to be 0 minus 3 squared times by +2. So 9 times 2 is 18. So that's at 18. So we're going to be looking something like this.